So this should be a fun video because you don't know what the topic is yet, but and I don't know if this is going to make any logical sense, but we're still going to go with it.
Okay.
Okay, so assessing and programming for reactive strength. We were just discussing and you walked through the damping effect, and you said that the damping effect in regards to the inside out model of reactive strength as a special strength is a top-down component. So it's like the red muscle tissue learning how to tune the white connective tissue to dampen the oscillation.
hmm
Okay.
hmm
So as I'm listening to you describe this, I'm
hmm
also thinking about like cases that I've seen, right? Where it's like if you don't understand programming, you're not going to make if you don't understand programming for reactive strength in a clinical setting, you are not going to get that person to point B. Okay, so stay with me.
hmm
So think about it this way. This is the link that I think that exists. So if there is abnormal connective tissue, so somebody comes to you in the clinical setting, or you're a strength coach, and they
hmm
start to complain about abnormal, what we would know as abnormal force transmission or
hmm
abnormal load transmission. So
hmm
connective tissue stuff.
Okay.
Okay, so they have abnormal connective tissue. They don't know that, but they're coming to you and they say, "Hey, I'm having this issue," and then you identify this is a bottom-up reactive strength thing.
hmm
Okay, won't they also have neurological shielding? Because if the neural network is responsive, so if the neural network is at point B and they're training
hmm
their neural network, isn't the
hmm
neural network going to send more top-down stuff to make sure that it can handle the load? And that will be felt as like shielding or tightness.
Yeah, definitely.
Okay. Because because we've written pieces on how tightness, neurological shielding, leading indicator that there's a bottom-up reactive strength issue.
hmm
We're saying that like, listen, when you're doing a point A intake and you're trying to figure out what do I need to program for this person, what you are doing is you are literally, if they start to say, hey, I'm getting tightness or shielding, that means the neural network is not interested in a joint going into range of motion for a shield or in tissue going to length if it's tightness, or both.
hmm
And a lot of times that's top down shielding, kind of like the bottom up stress shielding of connective tissue that shows
hmm
that there's abnormal connective tissue.
Yeah, I mean, yes, I would say so.
Okay, so does this mean that when you've identified bottom up biological stuff, that there should be essentially like a top down more damping effect? Like that should just be more present there. But that's where it's like from a program, do you understand what I'm saying? So what I'm saying is like there's abnormal connective tissue, right?
hmm
And so now what they're complaining of is shielding. So they're shielding
hmm
the joint and its tightness within the tissue.
hmm
Okay, that means that that
That's an
shield
that's it. That's an overdamped system.
exactly. Okay, which now this opens up this so and that's how that could be an indicator in real time of as to what to do. Because now you're saying the neural network of absolute strength is shielding the joint and it's not letting the tissue go to tightness. So if that's the case, because this is what I see all the time. I see this all the
Uh-huh.
time, this finding. And this is inevitably what I do. I always err. I go, okay, I can program for whatever I want, but I'm going to program for bottom up biological stuff.
Okay.
And it's funny when they start to do like so anybody that's programming for reactive strength in the clinical know that they're using the internal isometric continuum. So that's what I'm using, but the biological side of the continuum.
Okay.
You with me?
Yep.
Okay, so here's what'll happen is I'll start to put in those inputs, like biological based inputs, and immediately the over dampening system will no longer dampen. And I don't know if that's maybe just fatigue, but then I'll start to get tissue behaviors of tension.
Got it.
So, so like is there a heuristic in there, right? Like, is there because that's how I've been programming in real time. Because, like I said, I see this a lot. So anytime I see, hey, in your words, I have an overly dampened reactive strength issue where I'm getting all of this top-down support because the bottom-up biology is just shit. So if that's the case, it's not to dampen it because this is what I see all the time. And I talk like you probably do the same thing. They'll be like, "Oh, well, I'm taking down the dampening." But let me let me shouldn't it be you should stimulate the biology and the stimulation of the biology will then take the dampening, lower the dampening. It'll retune the dampening.
I think there's a, I think there's, I think you should need, I think you need to do both.
Okay, I'm not saying that you okay, yeah, yeah, yeah. You're right. You're right. You're right.
I think you need to do both.
So you're talking about
I think the heuristic, I think the heuristic in there that means something more in depth than maybe what most people would get out of that finding is that if you have neurological shielding, it is not necessarily a, and I say neurological shielding that is stopping a movement behavior of some sort, because neurological shielding at the end range of a behavior that somebody needs is not necessarily the same. Well, it's not the same. But if you get neurological shielding that is hindering a movement behavior that an athlete needs at the level of competition, then the heuristic is that the